Good afternoon, YouTube. Coming at you again with another math live stream for the SHSAT, the SHSAT. I'm Greg from GregsTutoringNYC at gmail.com. My email path is shown at the bottom and in the description. So just been doing a ton of videos here about a whole bunch of math and ELA and standardized test related stuff. This one is SHSAT specific. So what I've been doing on this kind of lightning round thing is just taking bite-sizable pieces, not too bad problems, and then just taking off bite-sized pieces of that. I tutor for a whole bunch of things. I do private one-on-one tutoring. I can also tutor in groups. So if anybody has a middle school student who's interested in taking this SHSAT, please contact me. I'm sure we can work something out. I'm a great tutor. I'm also proud of what I do here. So with that in mind, let's just jump into here. So I have a whole bunch of problems. I'm trying to categorize them that I've used over the years and so on. So let's just jump into some of this. I'm going to try to write neatly on some of this. So here's the problem. If 20%, let me make sure the YouTube is going. Yes, it is. Actually, let me try to move this over so I can see the comments at the same time. All right, that should work. If 20% of a number is 44, what is 30% of that same number? My handwriting's still atrocious, but so 20% of a number is 44. What is, it's not 15. What is 30% of that same number? Right? So again, if you're not getting this, this is kind of basic algebra. They don't actually call it algebra, but you can have this as early as 3rd grade. It's definitely a 5th grade problem, and absolutely a 6th and 7th grade problem. So again, depending on your background, this is something that you need to at least have as your basics when you do the SHSAT. You need to have this down pat that you can figure this out. All right. So there's actually 2 ways to do this. One is logical, and the other is algebraic. Is this coming through focus? No, it's not. All right, there we go. So 20% of a number is 44. What is 30% of that same number? So what I like to do is I read my problems. In this case, it's just right there. It's in our face. So I want to map the English into math. So it says 20% of means multiplication of a number, let's call it n, is means equals 44. 20% of a number is 44. Now it just becomes a normal math problem. 20% of n is 44. So we need to solve for n. We're going to divide both sides by 20%. Or in this case, we can multiply by 100 over 20. That cancels out, right? So whatever we do to one side, we do to the other side. Right? We can do 2 into here, get 22, 2 into here, get 10. So we get 2,200. Actually, we could have done simple just by using 5 here. In any event, I'm writing too sloppy here for my own sense. We have 20% of n. We're going to divide both sides by 20. We have 22, so we're going to get n is equal to 22. Hey Leo, how you doing? My mind is crumbling in this second. I'm zooming around today. I started this lead. I couldn't get connected. Um, 20% of a number is 44. What is 30% of the number? Something I wrote this wrong, I think. Yeah, I did actually. Ah. Anyway, if we approach this logically, 10% of the number, if 20% is 44, then 10% is 22. All right? Let me try this over. We have 20% of n equals, I did this before I started to run through it, 44. So we get 100 over 20, that's 5. So we get 220. So n is 220. I don't know why my brain froze up on this. N is 220. All right? And we can prove this is 20% of a number if we divide 220 by 5. Okay, 5 times 4, we get 2 left over, we get 44. Okay, so now the question is, what is 30% of the number? We can redo that. So now that we actually hash the number, we have 30% of 220. All right, we can cancel these two out, and we can cancel this 0 with this. So we get 3 times 22, and we get 66. All right, so that's the algebraic way to do it. Sorry, my brain froze here. It happens to everybody. By the way, that's the problem. I'm doing this live. I'm speeding around. You don't want this kind of brain bloop to happen during test time. Anyway, we can look at this logically, that if 20% of a number is 44, that must mean 10% is 22, right? It's just twice. So if they're asking 30%, then it's going to be 3 times that. And when you get the 66 back, we're still going to get the 66. So you have 2 ways to do this and to double check it, okay? Let me see what other problems I have. How about something like this? The square root of 1%. Okay, this is kind of a cutesy example because you normally don't see something kind of written this way. So what is the square root of 1%? Okay, most kids are going to say that it's 1. Because the square root of 1 is 1. This is 1%. So the question is, what does percent mean? It means divided by 100. So what we're looking at now is 1 over 100. That's 1%. Right? So when we have the square root of an x over y, that's the same as the square root of x over the square root of y. So this equals the square root of 1 over the square root of 100. And that's equal to 1 over 10. So the answer is a tenth. In fact, we could say the answer is 10%. Because they're equal. So the square root of 1% is 10%. Kind of sounds counterintuitive, but that's the way it goes. And we can work backwards as well. If we square this, so 1/10 squared, we're going to have the numerator being squared, be 1 squared over 10 squared. So we get 1 over 100. So we come back to our original number, which is equal to 1%. All right, so that works out. Let me see what else I got going on here. All right, I have a slightly more involved one. I'm going to have to put it into a file. So give me 1 second. And hopefully I typed it in right. I typed it in just before we started. That was one of the reasons why we were behind. So let me see here. 1 second. In the meantime, you guys should be full blast and you're studying. The test is in less than 3 months now, I believe. And that means you have about a dozen weeks or so on. So you should be starting to plan a lot of your, how you're proceeding forth with starting to consider your pacing, starting to consider what areas you're strongest in, what areas you're weakest in. Starting to think about, I'm not talking about resolving them, just start to think about these things. Starting to think about so there's basically the ELA versus the math, and within the math is the gradient versus the multiple choice, and within the ELA there's the reading comprehension versus the revising and editing versus the grammar, and even on the reading comprehension part, there's the poetry part. So kind of, depending on how you want to look at this, anywhere from two to 6 to 7 parts to this, all right, which is something you want to consider about how you're going to approach these things. All right, let me get this on the screen now that I have it typed in. All right, there we go. All right, let me move this down so that when I write the answer out, we can, that way I don't have to move. All right, so a test has A questions. Let me get a scrap paper here too. My fan's blowing this around too. A test has A questions, where it says 2, 4, 5, 10, whatever. Answering a question right is worth B points. Answering a question wrong is worth C points. Not answering a question is worth 0 points. If a student answered E questions and got F of them correct, what was the student's score? And then I'm going to give considerations for what some of those things could be. All right. So this is kind of interesting. So I'm going to kind of view it graphically first. So we have a question. The question can be basically resolved in 3 ways. Okay, and if you want to pause the video, by the way, you can do that and try to solve this. There's probably a few ways to solve this. So a question can be correct, blank, or wrong. All right? And it's telling us that, let's see. So if a question is right, it's worth B points, and B is 5. Okay, so if it's correct, it's worth 5. It's telling us that if a question is wrong, it's worth C points, and C is 0. Wait a second, that was wrong. Yeah, C is 0. And if it's telling us if we leave it blank, it's going to be worth D points, and D is worth 2. So that's our scenario. All right? So answering a question, leaving a question blank is worth more than getting it wrong. That's how this particular test is scored. Okay? So then, so that's kind of how the grading is set up. So there's also the exact test that this person took. So basically, so this is the scoring. This is the taking, really, if you're actually taking it. You have a bunch of questions, right? And basically, you can either answer them or leave them blank. Okay, if you answer them, you're going to get it correct, or you're going to get it wrong, right? So let's fill in what it says she did. It said she has 8 questions and 8 was 20. So she has 20 questions, okay? It says if the student answered E questions, so E is 10. So she answered 10, which means she left 10 blank, right? And she got F of them correct. F is 5. So she got 5 correct, which means she got 5 wrong if there was 10 of them. All right, so now that we have everything laid out with the 2 things, and we can kind of throw this away if we want. I was just trying to map this and logically decipher it, but it's there to be used. All right. So if a correct answer is worth 5 points, that means she got 25 points there. A wrong answer is worth nothing, so she got nothing here. And a blank answer is worth 20. So she got, 2, so she got 20 here. So her total is 25 plus 0 plus 20. So she gets 45 points here. All right. All right, let me see if the stream's still going and so on. So this one is a gotcha from a few levels. First of all, the problem is forcing you to replace the A, B, C, D, and E and the F by their values. It's then trying to get you, because there's a multi-possibility scenario laid out here. So it's a weird, it's a true multi-step problem. And you have to solve the multi-step simultaneously, because if there's 20 questions and she answered 10, you have to figure out this 10. And if she got 5 right, that means she got 5 wrong. So the question leaves stuff out and includes stuff. And then there's the obfuscation in a way that she gets more points for getting the wrong answers than if she blanked them out, or vice versa, or whatever that scenario was. So it's a fun problem. All right. So I see there's a few viewers. Anybody have any questions on what I'm doing? Yes, no, maybe? Come on, I'm trying to get an interactive stream, people. We need to jazz this up and liven it up. Give me 1 second. I'm getting a notification here in the middle of this. All right, so let me look at some of the other ones here. Let's see, what else do I got here? I typed a whole pack of stuff into a file. Again, this is a lightning round, so we're not going to go for an hour here, at least not that I think of. All right, here's one that's kind of related to something I did yesterday. Let me try to get a scrap paper with enough space on it. So the question is, what is the sum of the GCF and the LCM of 20 and 28? Okay, so this kind of hits home about some of the stuff we did yesterday. Again, if you want to work it out and you're on the replay, you can certainly stop the video. So we're going to do the same kind of thing. Especially since we have to get both, I showed you a technique to get both simultaneously. So we're going to put both numbers up, and we're going to start dividing into them. 2 goes into 20 10 times. It goes into 28 14 times. Can we go another round? Yes, we can. 2 goes into 10 5 times, and it goes into here 7 times. There's no more common divider here. So if we go this way, we get the LCM, and if we just go here, we get the GCF. So the LCM is equal to 2 times 2 times 5 times 7, which is 35, 70, 140, I believe. Let me do that backwards. 4 times 5 is 20. Yep, it's 140. And the GCF is equal to 2 times 2, and that's equal to 4. All right? So the question is, what is the sum of the two of those? So it's just 140 plus 4, and we get 144. Because some kids are going to get bent out of shape. What do they mean the sum of the GCF? They're asking to get each of these independently and just add them. It's the sum of two numbers. These are the two numbers. So we're going to get 140 and 4 and just add them up. Okay? Hello, Alicia. How you doing? Haven't seen you in a week or so, or whatever. Hopefully things are going all right. I've done a ton more videos, so catch up. All right, I have a nastier one. I'm not sure if I want to do it. Let me see what else I have here. Here's a similar one, since we're talking to LCM and GCF as well. Calculate the smallest number into which both 24 and 32 divide evenly. Yeah, it's the summer. You gotta leave room for relaxation and leave room for play as well. That said, figure out where you are in your SHSAT study, because if you're interested in going to one of these schools, the test is nasty, and just pace it out. You still have 12 or 13 more weeks, depending on how it is, and just keep that in mind, because you don't want to find out, in 4 weeks, the week before school, that you'll not have enough time based on what is going to happen in your grade 8 classes. Depends what school you go to and what other projects. Some schools give you summer homework and all that other stuff, but they seem to have stopped a lot of those packets and so on. In any event, so calculate the smallest number into which both these can divide evenly. So let me just use that same strategy so we get used to it. It's basically asking for a multiple here, a common multiple. It's basically asking for the LCM. So we have 2 goes into 24. We get 12 and 16. 2 goes into 6 and 8. 2 goes into this, and we get 3 and 4. 4 can still go. So we're not going to prime it all the way down. In other words, if you got a prime factor tree, we would still have two 2s, but we're done at this point. So the LCM is this here. So we're going to get 2 times 2 times 2 times 3 times 4. So that's 12, 24, 48, 96. Let me work backwards. 2 times 2 is 4 times 8. 8 times 3 is 24. 24 times 4. Remember, I told you you double, you get 48. You double again, you get 96. So I went both ways, and I got the 96. All right, so this is a cutesy problem too. We actually did the double thing. We don't need the GCF. We just needed the least common multiple. And you could tell this, this is really the clue in for the GCF. But this is another one where those were only suggested ways to approach it. What we're really looking at is the smallest number divisible by both. In the GCF case, we're talking about the numbers themselves being divisible. But we're talking about another number like 96 being divisible by these two. It's a different question. All right, it's a totally different question. Whereas the greatest common factor of these two is 8. 8 goes into here, and 8 times 4. That's a different question. That's the question is what factor divides into these evenly. This question is what number do these two divide into? So be careful when you see divide evenly. That was my my gotcha, my shout out call yesterday. All right, let's see, how far have we gone here? 26 minutes already? Did we really go 26 minutes? Let me see if I can find another problem. We'll just keep going. I feel kind of lethargic today too. Not sure why. The week's probably just catching up on me. So, all right, let me bring that back, make sure the stream is still running. Of course, if you guys have any questions, please toss them out there. I may or may not do them, but I could certainly do them on another stream. Let's see, what do we have here? What do we have here? I have another problem, but it might take too long to do. All right, yeah, let's do this one. The product of two numbers is X and their sum is Y. What is the positive difference between the two numbers? And I'm off the screen here. So the product of two numbers is X, and their sum is Y. What is the positive difference between the two numbers? All right, so I have to give you the numbers. How about we do 57 and Y is equal to 22. You have to do both ways. You have to do both ways. Is it better to tackle tons of problems to understand topic, or is it better to do one problem and do just that one problem to understand the topic? Well, first of all, you can't understand the topic just by one example. That each topic is too big. It covers too many things. Just like the LCM case where I covered the negative numbers, the zeros, there was some undefined behavior. So each example can't do that. And by the way, that's one of the problems with standardized testing. Even if you back off just to say the state test. For instance, if you're doing, say, grade 4 math, there might be 200 topics. But the grade 4 math state test, it might only test you on 75 of them. And what it might have is a common core of 50 of those questions. And each year they add a different set of 25. So they could go on for like 5 years and still not cover all the topics. And then furthermore, even out of the 50 common ones they give, they can't ask every question about every subtopic. So there's an infinite number of questions. So the best way to do it is just keep preparing, doing random number of questions, random number of topics, and then specific questions and specific topics. Like I did the GCF ones about GCF, but you need to know randomly, oh, is this a GCF problem? Is this a square root problem? What about exponents? This is where, and then it starts getting creative. When we move away from, let's say, the state test into the SHSAT, the SHSAT is about creativity. It's about thinking out of the box. The state test isn't really about that, okay? So this yin-yang that happens with everything. So your question is all the above and more. You have to do even more than what you're saying. But it's good to focus, because when you're figuring out your strengths and weaknesses, you have to know where you're screwing up for sure. And it's also just as important to know where you're doing well. But once you know where you're screwing up, you can focus on those problems. That's why I say, like, you shouldn't just take a practice test and say, oh, I got these wrong, what's the right answer? And then just go take another practice test. That's a bad strategy. Okay? So even though some of us are just throwing up random questions and so on, it's just, that's due to the constraints of YouTube, for instance. But there's another approach. When I'm one-on-one on a kid, I'm crawling into their head. I'm crawling inside their brains to figure out what they're knowing and not knowing. And we're beating to death a lot of issues. And this is one-sided. I get to ask them questions when I'm one-on-one tutoring. That's I think a critical piece of detail and information that people doing this on their own are not considering or can't consider. I understand there's economic concerns and other stuff like that, but it's a tough nut to crack. And getting those eyes and ears from an external party like me, who's an expert on all these questions and so on, is worth it. And it's going to enhance your thinking process. My job is not to give you answers to the questions. My job is to get you to think cognitively, think creatively, consider what the question's about, and add stuff to your toolkit. You have a toolkit of problem-solving techniques and problem-solving strategies and ways to break down a problem or even build up a problem. That's more important than actually knowing, what some of the details here are. So I'm giving you kind of a longest answer to the question, but you kind of have to do all the above. All right? So let's go back to my question here. The product of two numbers is x, and their sum is y. What is the positive difference between them? So if the product's 57, right, what we really need to do is look at the factors. And this is my standard 3 and 19. And I know it's 3 because this adds up to 12. And 12 is divisible by 3. I can also run that through one time. This is equal to 12, and I can run it through one time, add it up again, and I got 3. So I know this is divisible by 3. I know it's not divisible by 2 because it's not odd. It's odd. So I get 3 times 19. This is one of those numbers I kept telling you guys to remember. So this bug is done. This bug is done. And then it says, and the sum is y. So is 3 plus 19 equal to 22? Yes, it is. All right? So I figured out which of the factors, because there could have been other factors. If I had a number like 12, there's a whole bunch of factors. 1, 2, 3, 4, 6, and 12. So there's a whole bunch there. So what you'd have to do is figure out which of the two that would add up to whatever they're saying the y is. So then they're saying, what's the positive difference between the numbers? Well, we have two differences. Difference means subtraction, right? So we're talking about terminology here. We have 3 minus 19, right? That's equal to minus 16. Or we have 19 minus 3, and that's equal to plus 16. So it's asked for the positive difference. So we're not doing this one. Sorry, that's off the screen. We're not going to consider that one. We're going to consider this one. So we get 16. All right? So this is kind of a commonest problem. It'll come up in a lot of these kind of standardized tests. Could come up on the SHSAT. Could come up on a whole bunch of the others. So if anybody's watching this, even though I made this SHSAT specific, it also applies to the SAT. It could be on the ISEE. It could be the SSAT. It could be on the PSAT. It's probably too simple to be on the Hunter College High School test. The Hunter College High School test is harder than the SHSAT. At least I believe it is. Plus it has a writing section on top of it. So, all right, give me one more second. All right, let's do another problem. Here's a cutesy one, a very cutesy one. So we have 2 times 1 minus a half plus 3 times 1 minus a third. Let's see, can I get that fitting on the screen? Let me do this. Plus 4 times 1 minus a quarter, going up to plus 10 times 1 minus a tenth. Okay, what does that resolve to? So I have 2 times 1 minus half, 3 times 1 minus a third, 4 times 1 minus a quarter, plus ... So the rest of the missing info is analogous to this pattern, times 10 times 1 minus a tenth. So what do we get there? It's a couple ways to do this. Anybody have any thoughts? And again, if you're catching this on the replay, you can obviously pause the video. Well, if you consider that this is really A times B minus C, this becomes AB minus AC. So we get, it's 2 times 1 minus 2 times a half. This cancels out, and this is 2, so we have 2 minus 1, and we get 1. So this becomes 1. So this becomes 3 minus 1, right? So this becomes 2. This becomes 4 minus 1, so it becomes 3. So if we go up to 10, we're going to get 10 minus 1, or 9. So what we really end up is this 1 plus 2 plus ... plus 9. So does anybody know how to do that quickly? 1 is actually listed out and do the addition. But another way to do it is to add pairs. The next thing here must be 8. There's got to be a 3 and a 7. Okay? So you can get 3, 7, you can get 4, 6, and you're left with 5 by itself. So what we're going to do is divide up by 2. There's 9 numbers. 9 divided by 2 is 4 and a remainder. So we're going to do 4 times 2 and get 8. Right? Sorry, we're going to do, we have this pair 4 times, so we get 40 plus the 5 in the center, the number 5. So the answer to this would be 45. So that's a cute one as well, I think. All right, guys. I'm lethargic for some reason, and so I'm going to end it here. We did a while actually, longer than I thought. This is kind of longer than a lightning round. We're already into 40 minutes. So again, I'm Greg from GregsTutoringNYC at gmail.com. Please email me any questions you have, suggestions for questions, suggestions for videos. Again, this on my end, there's still 12 weeks. Starting to tutor a whole bunch of kids. It's going to expand and get more complicated, so my time is going to be getting more valuable as the weeks go on. And it doesn't end at SHSAT, because I'm going to be tutoring Hunter kids and SSAT kids and ISEE kids, because all that's happening in September. The TACHS also happens at the same time. So there's a cascade of things that are just going to break loose at this point. Try to catch me when you can. And I'm trying to get kids done during the day right now. So around this time I'm freer. But it's going to end up flipping there when everybody goes back to school. And then weekends are going to get harder too. So all right, people, peace out and happy computing.